Hi, my name is Ramna. My personal blog is .netiq.com. If you want to receive my latest videos or updates on your Facebook or Google Plus, please go to the .netiq.com, and right side you see a like button. If you click on the like button, you will get my updates on your Facebook wall. And the same thing, if you click on the join this site, you will get the updates on your Google Plus account. Coming to today's topic, C# performance tips. Sometimes a small change in our code will really matters to a huge difference in the performance. Definitely, those changes, those are the kind we call it as the performance tips or whatever it may be. Few of the tips I'm going to cover here. The one is the string versus StrinBuilder and string format. Basically, string related operations, we need to be very careful because it's a memory wise there is an impact if you use the wrong one. I know that there is so many places, so many articles is already existed on this topic, but still I'm covering this, and I'm going to show a few statistics. If you use the string in the wrong place, how much the impact in the memory wise and the performance wise, CPU wise, and the garbage collection, how it is going to perform. And the same thing, I'm going to compare with the ArrayList and the list. The third one is the list versus the dictionary. This is my personal experience, the list versus dictionary. In a particular scenario, one scenario, if you use the list, that list, list of that object, particular object, that's caused a huge, the performance wise, it's a very, I noticed really a big impact. Basically, it took a lot of memory, CPU, in that particular scenario. When I switch to dictionary, when I change to my code to use the dictionary instead of the list, I see a lot of difference in the performance wise, basically in the memory wise and the performance wise. I'm going to discuss that scenario. Definitely, if in your project you have that such type of scenario, you can rethink of using the dictionary instead of the list. I have my C# 3.5 console application. Here I have a different static methods for each topic, and I'm going to cover one the points wise. The first I'm going to cover the string versus the StrinBuilder. Get concatenated string. If you go to this method, basically here what I'm doing is I have a local string variable and I'm just looping that to 1000 times, and I'm concatenating the string. Basically, I'm doing the strint is my string variable, strint equal to strint plus I'm adding this integer. So I'm looping 1000 times, I'm concatenating the 1000 times. That means string strint equal to strint plus I. What exactly it is doing internally is whenever you concat using the plus symbol, it's every time it's creating new string object. Internally it is going to create a new string object, and that memory, that reference is going to update with the strint. So every time it's created some temporary variable like temporary string object, that temporary string object is going to finally assign to the strint. So you are looping 1000 times, it's going to create 1000 string objects, and final the string is going to, every time it's going to replace with your strint memory reference. That way, whenever you use the string with the plus concatenation, it is going to definitely is going to cause to create a n number of depends upon how many times you are loop through, how many places you are concatenating. Depends upon that, it's going to every time you create a new object, that is going to consume a lot of memory. It's going to use a lot of bytes of the memory. And the garbage collection point of view also, if you create a number of more objects, it's going to move the objects to different generations. I'm going to cover that in a little bit later. I'm going to run this. I want to make sure I'm copying the concatenation string and printing here and rebuild this project. Here I am using the CLR profiler. It's a really good tool to to analyze your code performance. It's going to give details like how much bytes of the memory it is consuming, the garbage collector performance, and generation 0, generation 1, generation 2, how many objects are moving to each generation, and it's really giving a very good the statistics. It's really good to means understand those statistics, and you can gauge your code the performance. If you don't have the CLR profiler, please go to the Microsoft.com and search for the .NET CLR profiler and download. It's a free download. I'm just running this. I'm just start application. Here is my console application exe. I'm running this from here. If you see the background, it's run that and get connection string. After executing that function, I'm just printing the get connected string. This and I'm just killing this application. This is the statistics. It's given by CLR. I'm first covering the garbage collection point of view. I think we already aware of the what is the generation 0, generation 1 and generation 2. I'm just covering the summary of what is this, and basically our topic is not on the garbage collector. So maybe in future I'm going to come up with another screencast by covering the garbage collection, how a garbage collector is going to perform in the .NET. Yeah, coming to here, we have a generation 0, generation 1 and generation 2. We have separate buckets, just to consider it as a separate buckets. Whenever the object is created in the .NET created by the .NET application, that object is going to first, all the new objects is going to be part of the generation 0 bucket. So the .NET garbage collector will frequently check the generation 0 bucket. Is there any unused objects? Means application is not using the objects. It is going to release those objects. The memory is releasing, and the memory is going to use by the application. So the generation 0 bucket is going to .NET garbage collector frequently visiting the generation 0. If you are creating more objects, like an n number of objects by our application, all the objects first comes to the generation 0, then the older objects is going to move to the generation 1 bucket. If the generation 1 bucket is going to fail, then the older object is going to move to the generation 2 bucket. But the .NET garbage collector, the frequency of visiting the generation 1 bucket and generation 2 bucket is very less compared to the generation 0 bucket. So the generation 0 bucket is visiting the generation 0 bucket frequently, so it is releasing the objects frequently. If any object is moving to generation 2, means the frequency of visiting the generation 2 bucket is very less, so the release of the object scope is also very less. So your object is still existed for a long time. So if you see that your application objects are creating more in the generation 1 and generation 2 bucket, means it's not a good sign. If you see that your application is creating all the objects is going to part of the generation 0 bucket, definitely it's a good sign. Your objects is going to properly releasing. If coming to this example, if you see in the generation 0 heap bytes, we have a heap bytes, and generation 1 heap bytes and generation 2 heap bytes. That means that few of the objects is part of the generation 2 and few of the objects is moved to the generation 1. And even the memory wise, also see if the 7 digits of the memory you are seeing, 7 digits of the bytes you are seeing. The relocated bytes means it's going to be part of the generation 1 bucket related objects bytes. I'm not going to explain, analyzing all these results, but somewhat, we are seeing some negative sign. We are seeing the few objects in the generation 1 bucket and generation 2 buckets, and some memory allocation is also distributed. 7 digits of the memory you are seeing this. I'm taking the print screen of this, and I'm placing the MS Paint. I just copied here in MS Paint so that we can compare the results when you run the next StringBuilder method. That way we can see the performance wise the differences. Just calling the get concatenated SB string, that means StringBuilder. Sorry, I'll go to this definition. Here if you see, I just created a StringBuilder instance and appending the I value. That means that whatever I am doing in the below, I am doing the same here. Just here I am concatenating with the plus symbol with the string object. Here the StringBuilder object. The StringBuilder object, what it does is, whenever you are appending, it's not creating a new string object. Whenever you append with a new value, it is just updating the reference of the StringBuilder object with the new value. So internally it is not creating a new string object for every concatenation, means for every append. So that is a really benefit. It's not creating thousands of the string objects. because you are looping the 1000 times, it doesn't mean that you are using, it's not creating 1000 string objects. That way you are controlling the memory, and you are controlling the new objects also. That way your garbage collector also will perform very effectively. We see the results. Once we run this, we can see that results and compare that. I'm just rebuilding this project because I changed the calling method. I'm calling the get concatenated SB string. Here I'm printing the get concatenated SB string. Go to the CLR profiler folder. I'm just running this exe and opening that. Yeah, background, it run that and see get concatenated SB string. It's executed that method, and if you see, wow, amazing. I'm just comparing these two results side by side. Here it took almost 7 digits of the bytes. Here it took 6 digits of the bytes. It's a million bytes, 3 million somewhere, more than that, and it has 6. If you see relocated bytes, nothing, 0. If see heap bytes, 0, generation 0 heap bytes unknown, 0 1 heap bytes unknown, 0 2 means it doesn't have the really, there is no object moved to the generation 1 and generation 2. All the objects created in the generation 1 bucket and released from the generation 0 bucket, all the objects is created, means released from the generation 0 bucket itself. This really is a good sign. Memory wise also you see a lot of difference, it's very significant difference. It's a lot of difference. I hope better we use the string builder rather than the string whenever we are dealing with the concatenation, means string concatenation, string manipulations. And coming to the string format is also pretty much do the same like what the string builder do. The only the difference is the place of using the string format is whenever you are logging the statements, like your log files, logs, like tracing, trace logs or debug logs. What are the log statements? You log with some static data along with the dynamic values. I'm going to show you one method here. The greeting. Here the greeting is the one method. Just I'm passing the first name and last name. I want to print like my result in a hello Mr. the first name plus hello Mr. plus first name plus comma, this is another string, and plus the last name. If you do the same way, hello Mr. plus first name, it's going to create one string object. Again hello Mr. plus first name plus comma is going to create one more object, and again it's going to create the last name. It's going to create totally 4 objects of the string objects if you do this way. Either if you do use the string.format, you have your format like hello Mr. and there is a placeholders 0 and 1 placeholders. In the 0 placeholder you are saying that use the first name in the 0 placeholder, and the 1 place use the last name. Basically it do the same way like what the string builder do. It won't create a multiple string object for every concatenation. It will exactly behave like the string builder. The usage of the string.format and string.append is depends on the the situation. Basically in the log, like this type of statements, we use the string.format. Yeah, coming to the array list and the list, that is our second topic. Basically array list and the list both do the same way, exactly the same, it behaves the same. The only difference is the array list will accept the input as the object type. I'm going to show you one example. Where is that array list? Yes, this is my array list example. Here if you see, I created a array list instance and I'm loop through this again the same. I'm adding the integer. If you see my add method signature, it is expecting the object as the input, but I am adding the integer as the input. Integer, basically integer is a value type, but it is expecting the object as the input. So internally, implicitly it does that value type to object type. That means the boxing, and the boxing and unboxing is going to happen in the case of array list. So if you use the array list for the value types, it is basically it do the boxing and unboxing. So the boxing and unboxing is going to cause some memory wise some impact. Basically it takes more bytes. I'm going to show that using the CLR. Here actually I'm calling the ArrayList example where we use the ArrayList object. I'm just rebuilding this project, and in the console.writeLine I'm printing the ArrayList example. Again I'm going to CLR profiler and just opening the same project. in the background you see ArrayList example. So kill the application and see the memory it is taking is 601, 6 digits of the memory, and we are good. Generation 0 1 2 3, there is no specific bytes and there is no relocated bytes. That means we are good. But the only thing is we need to compare how much bytes is taken by ArrayList and how much bytes is taken by allocated bytes for the list. Okay, I'm just taking the screenshot of this. Come on, yes, got it. I'm just replacing this. Yes, we're good. I'm closing this and closing this too. And coming, go to the. I'm just calling the list example here. Basically, list is basically strongly typed. Whatever the list of something is specified, so some type is specified. The type, it takes only the type. Means if you can add the type, you can remove the type. Basically, it's a strongly typed, so there is no the scope for the boxing and unboxing. It's expect a particular type and it takes that particular type. So there is no boxing and unboxing in the list case. So there is definitely there is a little bit or some percentage of bytes allocation wise you can see some difference. I am just running this example, rebuild it and go to the CLR profiler and start the application. Let's see, here go, list example, kill the application, see 576525. But definitely it's not a huge difference. There is some difference in the bytes allocation wise, memory wise. See, 576525 601135. That means there is some difference in the memory wise. The ArrayList took the more because of the boxing and unboxing. And coming to our third topic, as I mentioned, it's I have the personal experience on that. I will explain you what is that. Before that, I have an employee object. It is taking the 3 properties like employee ID, name and address. And go to the programs class. There is a populate employee list. Here what I'm doing is list of employee. I created the list of employee and I'm just loop through to 1000 types, and to that employee list, particular employee list, I'm adding the new employee. I'm creating every time I'm creating a new employee object and passing the employee ID as the employee 1, employee 2. Means I'm just here I'm using the string.format. I'm not using the plus concatenation using the plus, and just employee, I'm 0 placeholder, I'm passing the I. That means that if 1000 times it's created, so 1000 employee IDs, employee emp1 to emp1000, and the name is also I'm doing the same. And after that, see here I created the 1000 employee objects and added to the list of the employees. Just imagine there you have a database is giving the list of 1000 employees in your select query. So in this I'm just again loop through the 1000 times and I'm finding the employee list, finding the particular employee whose employee ID is equivalent to emp of I. That means that 1000 times I'm just finding the employee from that employee list. This find operation is a bit expensive in the list. Here I am doing the search only on the employee ID. That means that my object, and out of my object has a 10 properties or any n number of properties, but my search filter is only on a particular on one column. That means here I am doing it on employee ID. In my project example, I am using a particular object. There I am doing it on a primary key. There is I am doing the search finding on the primary key. So I am not doing, after I got the list populated, list of the objects is populated. After that I am not doing any additions. I am not doing any more additions to that list. I am not removing any particular object. I am not updating any particular object. I am just using that list of the objects for retrieval. Retrieval means like to read the particular object data and displaying. Just reporting purpose I am using that list of objects. I am not doing any more additions or updations or deletion to the particular list of the objects. Then whenever the user wants a particular data, I'm just querying that list of the objects and retrieving that particular object and displaying to the user. That's what I'm doing here. Also I'm trying to same thing I'm trying to reproduce, just I am trying to search the 1,000 times and using the same list of the objects and printing the value. So if I run this method, the list, I'm just concatenating this and populate employee list. I hope you got the point. What I'm trying to say is, just the first time, one time you get the list of all the objects and you're keeping in a list, memory list, and you are trying to, next time onwards you are trying to query your list. And one more thing is, you are querying only on one column, particular key, one column. So you are querying on a particular one column from your list of the objects. That is the requirement, that is the situation. Okay, I am running the, I'm just rebuild this and running using the CLR profiler again. Come on, and it's going to print the 1,000. So it is printing, because every object is finding and printing, name, it's printing the name basically. 485, 470, 490. Wow, come on, 450. It's taking time. You're almost there, yes, good, we are done. Kill application. Come on, oh my god. I'm taking the screenshot of this results, so I'm printing over here. See here, it's take almost 1 2 3 4 5 6 7 8 digits of the memory. You see the relocated bytes, and you see some bytes for the generation 1 bucket and generation 2 buckets. That means that it's take a lot of memory, and the objects also, so many objects is created, and it's moved to the different buckets, generation buckets. Let's stop this application and call the other method. I'm going to here I'm calling the populate employee dictionary. Go to this. So yeah, as I mentioned, I'm just querying, I'm just finding the employee based on one column, that is employee ID. So that is the one key thing we need to remember. Here, that's why instead of the list, I am trying to use the dictionary. My dictionary signature is, it is taking the input as a string and the key as the value as the employee. I am just binding the string key to an employee object. So I am creating an employee dictionary, and I am populating the employee dictionary. 1,000 objects I am creating as same like employee dictionary dot add. I am adding the employee ID as the key value, means it's taking the string and employee. I'm just taking the string.format of employee ID, and I'm creating the new employee object the same way what we did in the list side. Only the difference is the key is going to hold your employee ID, and your object is going to hold the everything. We have a mapping with employee ID with associated employee object. So I just created the 1,000 objects and added to the dictionary, and again I'm looping the 1,000 times, and I'm printing the each employee, doing this based on the search, like finding the employee ID, where employee ID matching to this employee of I. So I'm finding from the dictionary and printing here. Definitely you see a considerable, let me rebuild this project. Rebuild this project and run from the profiler again. See, wow, amazing. It just finished it in wow, there is no generation 1, generation 2 bytes, and there is no relocated bytes, and only 1 2 3 4 6 7 digits of the bytes. If you compare with the wow, see, it has a 8 digits and it's starting with 89. So definitely there is a lot of difference in the memory allocation wise, allocated bytes wise, and the garbage collection point of view and everything. The dictionary is really done a very good job. Remember it, when you want to do only one on particular one column, if you want to do a search, then use the dictionary. Then, and coming to the list objects, generally we use whenever you have all the operations in place. Like, even if initially you populate a list of the objects, and your application is going to update the list of the objects, either removing the objects, adding the new objects, and updating the old objects. In that case only you better go with the list objects. You want to go, means if your requirement is just to populate once and use the just retrieve the objects and displaying purpose, in the reporting purpose, then don't go with the list is a costly operation. Definitely it's a list is an expensive operation. And then coming to, if you want to use a filter, like search on particular multiple columns, then here you have a one column, that's why you just mention that column as a key and value is specified as an object. If you want to do a search on the multiple columns, then what to do? How is the performance is going to be impact if you use the list and if you are going to use the enumerable? I'm going to cover that in my next screencast. I hope this helps you in your in the performance wise. If you want to know, it's going to helpful in at least in your performance. It's going to improve in your projects also. Thank you. Bye.